Hello, my mathematicians. This is Miss Foster with Math in Focus, Grade 4, Chapter 7, Lesson 5, where we fully explore the relationships between fractions and decimals. They're both about pieces and parts, but decimals are part of our place value system. And where this is going to get tricky is using equivalent fractions. So then we're going to think, well, let's think about 10. Can I divide 10 in half? Yes, I can. So 1/2 would be equal to how many tenths? Well, 1/2 would be equal, let me see, to make halves into tenths, I have to multiply the number of pieces by 5. And so I'm actually going to do that again with both the denominator and the numerator, because 5/5 is 1. We're just changing the size of the pieces. 1 times 5 is 5, 2 times 5 is 10. I think we can agree that 5 is half of 10. And this is the kind of equivalent fraction work that's going to crop up in our lesson today. Now, of course, they love those number lines in Math in Focus, so we're going to draw a bar model and a number line and find the missing numbers. So the bar model is this pink rectangle here, and the number line is beneath it. You can see that the bar model has been divided up into 1, 2, 3, 4, 5. And notice, please, that it starts at 0 and it ends at 1. And it does that on the number line as well. I believe we had a chance when we were looking in fractions, studying fractions, to see how bar models can be a representation of a number line. Now, they're asking us to fill all of this in, and they say that this is 2/10 and this is 3/5. Well, 3/5 is equal to something with tenths, isn't it? But it looks like just from this fraction right here that they want this to be in its simplest form. So that's easy enough. 1/5 and 2/5 and 3/5 and 4/5. However, as you know, because they're part of our base 10 place value system, decimals will be using tenths. Now, if I were just to draw a line here, do you see how that is splitting every one of my pieces in two? That's like multiplying my fifths times 2/2. So the whole bar is 5/5 because 1 is equal to 5/5. So if I took 5/5 and I multiply it by 2/2 like we were doing in our fractions chapter, then I would wind up with 10/10. This is a beautiful visual example of what happens when we're using equivalent fractions. 10 is part of our number system, so we can use it. And that means that this right here would be 1/10. But as a decimal, I would write it no single ones, that little, hey everybody, got some decimals coming. The 0 out in the single ones place and 1 in the tenths place. This is 3/10. This is 4/10. And is 2/5 equal to 4/10? I believe it is, isn't it? I'm not going to take a lot of time with that, just point it out. This is halfway, it will be 5/10, and we can see it being equal to 1/2. Here would be 6/10. Well, 5 times 2 is 10, 3 times 2 is 6. It works. 6/10, 7/10, lots to write down here. Sorry about that messy decimal point. 8/10 and 9/10 before we get to one single one. If we didn't have that 0 in there, or I'm sorry, that decimal point in there, and all these zeros, wouldn't it be kind of like counting by ones? 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So many connections my brain is making. Now, they're asking us down here to express each fraction as a decimal. And I see that 1/5 is equal to 2/10. But it's also equal to 2/10 written as a fraction, isn't it? Because 1 times 2 is 2, and 5 times 2 is 10. Looky there. We already saw that 6/10 is equal to 3/5, and 4/5 is equal to 8/10. Number lines can really help you with the decimals, huh? Surprise! We have jumped down to the next set of problems. It asks us to express each fraction as a decimal. And something to keep in mind is that in the case of these fractions, they are already in their simplest form. 4 and 20 and 25 are part of our base 10 place value system, but fourths and 20ths and 25ths doesn't feel like that's true. So I need to get these denominators to work with either tenths or hundredths. Let's look at 3/4. Well, 4 times something will get me to hundredths. What is it? Ooh, remember when you learned to count quarters? 25, 50, 75, $1, or 100 cents. So 4 times 25 equals 100. That means to get this to be hundredths, I need to go ahead and multiply by 25 25ths. And that does seem like an awfully big number right there. It's not very simple, is it? But luckily, we know how to count quarters. And if you don't, it's a great time to learn. Let's count 3/4 there. 25, 50, 75. 3 times 25 is 75. So if the equivalent fraction is 75 hundredths, that also should be my decimal. No single ones, 7 tenths, and 5 hundredths to give us 75 hundredths. This is a nice chance to see why we always look and use that lowest place of value to name our decimals, because that tells us the denominator. Ooh, 17/20ths, that looks tricky. Well, 20 times something is going to get me to hundredths once again. 17 is prime. I'm not going to divide to simplify that fraction. Got to make it more complicated. Let's see. How many 20s in hundreds? How many 2s are in 10? The answer is 5. So if I multiply by 5/5, a form of 1, now I've got to do 17 times 5. Some of you are such snappy mathematicians, you can just rattle that off in your brain, and I'm sorry to slow you down, but I'm not that kind of mathematician. 7 times 5 is 35. I'm going to regroup my 10s up there and remember to add them in, and aren't you glad we taught you this year? 5 times 1 is 5, and 5 plus 3 is 8. So that tells me that this fraction is 85 hundredths, which will be the decimal 85 hundredths. And what about over here? 26 25ths. Well, first of all, I'm noticing as I write this down that this is an improper fraction. So I'm predicting right now that I'm going to have a 1. Let's see if I'm right. Now, I'm also thinking about this problem over here when we saw that there were 4 25s in 100, 4 groups of 25. So I'm going to use that to say, well, I'm going to have to multiply 26 25ths by 4/4 to get the denominator to be compatible with my place value system. So 25 times 4 is 100. Did that on the first problem over there on this row. 26 times 4. I could write it out like this, but it's only one group of 4 more than 100. So I think that equals 104. Now, I'm going to take this 100 100ths and turn it into that 1. But I've got this much. And look, if I drop the decimal point right there, do you see how it's almost exactly the same number? The decimal point just helps me organize and say, hey guys, I'm dealing with hundredths. Ooh, express each mixed number as a decimal. Well, this is not right here an improper fraction at all. So I'm just going to go ahead and write that whole 3 right there and get ready for my hundredths. Now, 13 50ths, we have to get those to be hundredths. 13 is prime, so I won't be able to divide to get to my hundredths here. So I think I'm doing hundredths, and I know that 50 times 2 equals 100, so I'm going to multiply all of that by 2 halves to get it to be hundredths, which works in our place value system. So 13 times 2 is 26. And how were you able to do that, Ms. Foster? I actually did 13 plus 13 in my head. No regrouping? That's the best kind of mental addition for me. Ooh, 24 25ths is not an improper fraction. So my whole number, 7, is right there. I'll just take care of that right now. Now, 25, as I learned up here, times 4 is 100. 24 is only one group of 4 away from it, which means it's 100 minus 4, which is 96 hundredths in this case. How about 22 and 4/5? Once again, I'm just going to write down the 22 there, and actually I'm going to move it because it's just too crowded right there for me. So I'm ready to go with that. 4/5 is not improper. There's no regrouping. But 4/5? Well, if I were to take 4/5 and multiply it by 2 halves, as I did up at the beginning of this lesson, then I would get myself to 8/10. And so, you know what? I can just stop there. I don't have to make it more complicated than that. That would be 22 and 8/10. And there's just more and more and more of that. This time they want us to take the decimals and make them into a fraction, which quite honestly I think is even easier. Here's how it goes. I'm going to write my whole number, and I'm going to use my decimal place for the fraction. Now what is this place? This is the tenths place. So my denominator needs to be tenths, 3 and 6/10. I think though, do you remember how when we were doing fractions, they always wanted you to express it in its simplest form? So let's go ahead and do that. 6 and 10 share a factor of 2. So 6 divided by 2 is 3, and 10 divided by 2 is 5, and we're right back at 6/10 equaling 5/5, just like we did up there before. 5 and 12/100. 5 and 12/100. Done. 4 and 35/100. 4, oh, I'm so sorry, you guys. I just rewrote the decimal. Ay, ay, Miss Foster, stick with your directions here. That would be 5 and 12/100. But I'm not done, am I? First of all, I keep talking while I'm supposed to be writing things, and then I write them wrong. Oh, Miss Foster, you are not helping the children to learn. The reason I'm pretty sure that I'm not going to be able to stop here is both 12 and 100 are even. So I know they share a factor of 2. But then looking at 12, I also know that 4 is a factor of 12, and on the problem up there, I knew that 100 or 4 times 25 equals 100. So I could divide both of these by, I could divide 12/100 by 4/4. 12 divided by 4 equals 3. 100 divided by 4 equals 25. And so the fractional version of 5 and 12/100 is 5 and 3/25. Now, Miss Foster, you're changing the decimal into a fraction. Let's do it right this time. Well, once again, I'm doing a mixed number here. I've got that 4. It's not going to change. 35/100. Is it in its simplest form? And I'm going to say no right away because I know that 100 and 35 both share 5 as a factor. So can I divide them both by 5s? Yes. And I'm going to say, we'll just keep that whole 4 there, that 35 divided by 5 is 7, and I know that because 7 times 5 is 35. We're practicing our math facts! Yep, this is why we want you to know them. Go play some games. Learn them off. Spend the whole summer. Okay, and then 100 divided by 5, well, 10 divided by 5 is 2. So 100 divided by 5 would be 20. And so this most simplest form of 4 and 35/100 is 4 and 7/20. Got 2 workbook pages to just practice this a bit. If you get lost or stuck, rewatch the video, play fractions with me, or draw some number lines or bar models. Will that help you? Go for it. Hey guys, thanks for playing with fractions and decimals with me. I had so much fun playing with you. Bye-bye for now.